So we're going to start with atoms and elements, right? So, and you're familiar with those, and they might be the same thing, and they might be something different. So we want to find out what are they, and what's the difference between them. So, an atom. What's an atom? So an atom, you read of a definition, it's the smallest unit of matter. Now, an atom, though, can be broken up into smaller units or subunits, or we call subatomic particles. And you probably know these as well. Right? We have probably know protons, right? And you've heard of neutrons and electrons. Now, as far as our study of chemistry in a biology course, we're going to find that some of these things are going to be of more concern to us than others. When we read a periodic table and we look at a particular element, so let's say here for carbon, for example. So carbon, in the periodic table, you're going to see number 6 up top here. That's what we call atomic number. Find out what is that? What does that 6 mean? Well, that is the number of protons. That's the atomic number. And that's what defines this element, carbon, or we could say this particular atom. So an atom of carbon is different from an atom of oxygen. It's different from an atom of nitrogen. How is it different specifically? How is one element's atom different from another atom? They all have these protons, neutrons, and electrons, but they have different numbers of protons. So a carbon atom has 6 protons. I'm not going to draw 6 of them, but just represent it there. Typically, we're going to have the same number of each. So protons, neutrons, and electrons will typically be the same. So if it has 6 protons, it's going to have 6 neutrons. However, the neutrons don't define this element. The protons always define the element. We can have variations. So we can have things called isotopes, which are different versions of this element. How are they different? They have different numbers of neutrons. Different neutron number. And we're not going to really go into these. Some people may go into carbon dating more so, but it's not something we're going to have a lot of time for. We're focused on other things. Now, there's electrons. Typically, we're also going to have the same number of electrons. So if there's going to be 6 protons, there's also going to be 6 electrons. And we'll get to this in a second. Though different elements are going to have different protons by definition, and the electrons and protons should be the same, we can also have one atom of an element, but yet different versions of that element that have different electrons. So if the electron number differs, if the electron number, say, should be 6, but it's not 6, it has more than 6, or less than 6, we're going to call those ions. Ions have different numbers of electrons, okay? So different numbers of electrons is an ionic version of an element. Different numbers of neutrons make isotopic versions of an element. But the protons don't change. If the proton number changes, it's no longer that element. It has become a different element. So if we're using the proton number, we're looking at a periodic table, we see carbon has 6 protons, and we're going to now draw a carbon atom. Put the protons and the neutrons together in the atomic nucleus. All right. Now you're going to see that word sometimes referring to other things. There's the cell nucleus. The cell nucleus is not the same. So I've asked students, what do we find in the nucleus of a cell? And sometimes students have said protons and neutrons. And that's you're talking about the nucleus of an atom. Nuclear just means core, really at the center of. So at the center of this atom are the protons and neutrons. At the center of a cell, not technically the center, but usually sort of at the core of a cell is its nucleus. So it's where the DNA is, where the genetic information is. So this is what we're talking about specifically for an atom. Now, electrons are not here. Electrons are not in the nucleus. The electrons are surrounding the nucleus and they're moving around in a variety of ways. We're not going to get into specific movements of electrons. That's for a chemistry course. But we're going to talk about the general distribution of the electrons and something we're going to call energy levels or shells. So if we have 6 protons, typically we're going to have 6 electrons as well, unless it's an ion. In this case, it's not. We're just going to start off with the most basic type of carbon. We'll have a shell. So in this shell, so we're going to call this an electron shell. And in this electron shell, we're going to find some electrons. Often when we draw them, we'll draw them and you might picture they're orbiting the nucleus, like the moon orbits the Earth or the Earth orbits the sun. And that's not true. That's not the case. They don't just move around like this. For drawing, for us, for me, for you, it's going to be easier to look at it like this. What we're going to know is that the electrons are found here. They're somewhere in this region around the nucleus. And in this closest electron shell, what we call the first electron shell, there are 2 electrons max. All right, we can't have any more than 2 electrons in this first region. Okay. But carbon has 6 electrons. So what about the other 4? Well, the other 4 then are just going to move further out. Okay, so we're going to have a second shell. So this is now the second electron shell. And it can hold a maximum of 8 electrons. 8 electrons. And this is going to be really important. Actually, that number 8 is going to be really important for a number of different reasons. So we have 2, and then there was a total of 6, so that means there has to be 4 more. All right, so we go 1, 2, 3, 4. So that's 1, 2, 3, 4, and there's 2 here, 5, 6. So again, somewhere in this region outside, further away from the nucleus, are these 4 additional electrons. So carbon has 4 of 8 maximum electrons in its outer shell. All right, so in that outermost shell, for this one it's a second shell. Now there can be more shells. All right, so you can have a third shell or a fourth shell. For the molecules the molecules we're going to build in the course, and the elements that make up those molecules, we're never really going to see more than 3 shells. 2 shells are going to be fairly common. Some of them will have 3. 3 is going to have the same rule. It'll also extend out to 8 maximum electrons. So it's going to be 2 in the first, 8 maximum in the second, and then 8 maximum in the third if we go over that, if we fill them up. That's the beginning. Now, I'll do one other element real quick, and then we'll switch gears to look at these main elements up here, the ones that are going to be making the biological molecules. We'll look at each of them, and then we'll look at how they interact. And that interaction will be when we get to bonding. How do they actually bond with each other? The bonding is going to involve the electrons. So how the electrons are shared between different atoms or stolen or what's going on, what's going on with electrons. But it's all going to be about them. So we're not going to focus much on protons and neutrons. Really, neutrons not really at all. Protons, because that's the definition of the element. Right? It's defined by atomic number, which is the number of protons. But we're not going to really focus on them too much. It's going to be the electrons where our focus is going to be. To give you just another example from up here before we switch over, we'll look at carbon. Say it has the 6, that's its atomic number. If we look at hydrogen, up here above it, hydrogen has an atomic number of 1. Okay. And how hydrogen is a little bit different is that hydrogen has, now that means 1 proton, right? By definition, there's just one proton for carbon. The thing is with carbon, it doesn't have a neutron. There's just a proton. So in its nucleus, at its core, right, we just find that one proton there, just sitting there. And that's it. One proton, no neutrons, but then one electron. Okay, it's going to have the one proton, one electron. So there's going to be an electron moving around that proton. Again, not in a typical, lunar type orbit, but in a region around that proton, you're going to find one single electron. Remember, that shell can have a maximum of 2 electrons max in that first shell. So what this is going to mean is that this hydrogen needs one more electron to fill that shell. That need to get that additional electron, we're going to talk about, is called electronegativity. That's the next topic. And that's what's going to lead to the bonding then between, say, a carbon and a hydrogen forming a bond with each other. Right, and that idea, that bonding, that's going to be the next topic. So that's where we'll start off. Each of the elements, putting them together.